Section 5.3 Interactive Assignment. A test to determine whether a certain antibody is present is 99.7% effective. This means that the test will accurately come back negative if the antibody is not present in the test subject 99.7% of the time. The probability of a test coming back positive when the antibody is not present, a false positive, is 0.003. Now suppose a test is given to 7 randomly selected people who do not have the antibody. Part A, what is the probability that the test comes back negative for all 7 people? And then Part B, what is the probability that the test comes back positive for at least one of the 7 people? So we need to pay attention to the words that are in this question here. Okay, so the question says, what is the probability that the test comes back negative for all 7 people? So the first thing we need to do is we need to determine if the events the test are independent or dependent. Now the 2 events E and F are independent if the occurrence of event E in the probability experiment does not affect the probability of event F. The 2 events are dependent if the occurrence of event E in the probability experiment affects the probability of event F. Now since the results of one test does not affect the results of another test, we're going to say that the tests are independent of each other. So now we know that the amount in question is, we want to know if it comes back negative for all 7 people. And we know that it's going to be negative if it's 99.7% of the time where it's not present. So the probability of it being negative is 99.7%, converted to a decimal is 0.997. Okay, now we're looking for the probability that all 7 are negative, which means the probability of test 1 is negative times the probability of test 2 is negative times all the way to the probability test 7 is negative. Okay, so that means that we're taking 0.977 and multiplying it 7 times. So it's the same thing as taking 0.997 and then raising it to the power of 7. And so when we do that on our calculator, we're going to round this to 4 decimal places, and we get approximately 0.9792. Okay, now in Part B it says, what is the probability that the test comes back positive for at least one of the 7 people? So we need to be careful and understand what this word at least one means of the 7 people. Okay, now the phrase at least, okay, means greater than or equal to. So we wish to find the probability that 1 or 7 or 3, 1 or 2 or 3 or 7 tests will come back positive, because we want to find out that it's going to come back positive. Now notice that these events are mutually exclusive, therefore we can say that the probability can be expressed as follows. We're going to say that the probability of 1 or 2 or 7 positives is equal to the probability of 1 positive plus the probability of 2 positive plus all the way to probability of 7 positive. Now, instead of computing each of these probabilities, we can say that the complement of at least one of these 7 tests come back positive can be used. Now, the complement of at least one test is positive is 0 tests are positive. That means that the event 0 tests are positive is the same thing as all 7 tests are negative. And we found this probability in Part A up here. We found that when all 7 tests are negative is 0.9792. So the complement rule states that if event E represents any event and its complement represents the complement of E, then the following must be true. We would say that the probability of event E is equal to 1 minus the probability of the complement of E. So now we're going to determine the probability that at least one test comes back positive using the information from Part A. So remember that at least one positive means 1 minus the complement of at least one positive. Well, the complement of at least one positive is 0 positives. Okay, so we're going to say that 0 positives is the same thing as all 7 are negative, which is what we found in the previous example. So we're going to take 1 and subtract what we got in that previous example, which is 0.9792, and then we're going to get the following. We're going to get the following. The probability is 0.0208. So the probability of at least one positive is 0.0208.